Hi students, today I am going to discuss the concept of linear programming problem. In many economic activities, we face the problem of optimization. So what do you mean by optimization? Optimization means either minimizing or maximizing a linear function. That means minimizing the cost or minimizing the labor or maximizing the profit or sales, like that. The constraints may concern about the availability of the raw materials, demand for the commodities, etc. In such a situation, whenever optimal condition is required, we adopt the linear programming models. It was in 1947, George Danzig and his associates introduced the concept of linear programming problem to deal with the problems concerning military activities. Now let us study the mathematical formulation of a linear programming problem. A linear programming problem consists of three parts. One is objective function, followed by a set of constraints and non-negative restrictions. Suppose maximize z is equal to c1 x1 plus c2 x2 etc. plus cn xn. I will call it as equation number 1, subject to the set of constraints a11 x1, a12 x2 plus etc. a1n xn less than or equal to or equal or greater than or equal to b1 etc. Last constraint am1 x1 plus am2 x2 etc. amn xn less than or equal to equal or greater than or equal to bm. I will call this set of constraints as equation 2, followed by non-negative restrictions xj greater than or equal to 0, j equal to 1 to n. I will call it as 3. Here 1 is called as the objective function, 2 is called set of constraints, and 3 is called the non-negative restrictions. What do you mean by objective function? The function which is to be optimized is called as objective function. Next one is constraints. The linear conditions in terms of equalities or inequalities imposed upon the variables to be determined are called as constraints. Next one, what do you mean by decision variables? The variables on whose values we have to take a decision are called as decision variables. Next, solution of a linear programming problem. Any set of values xj which satisfies the constraints of LPP is called a solution of a linear programming problem. For example, maximize z is equal to 3x minus y subject to 2x plus y less than or equal to 10, y less than or equal to 2, x comma y greater than or equal to 0. Here x equal to 2, y equal to 1 is a solution of a linear programming problem, because if you substitute x equal to and y equal to 1 in both the constraints, you observe that both the constraints are satisfied. That is why it is called a solution of a linear programming problem. Next one, feasible solution. Feasible solution. Any set of values xj which satisfy the constraints as well as the non-negative restrictions is called as feasible solution. In the above example, 2x plus y less than or equal to 10 and y less than or equal to 2. These are the two constraints. Suppose x equal to 2, y equal to minus 1. It may be a solution to the LPP, but it is not a feasible solution of a LPP because it violates the non-negative restriction, that is y equal to minus 1. Therefore, x equal to y equal minus 1 is not a feasible solution, whereas x equal to 4, y equal to 2. It is a feasible solution because these 2 points satisfy the constraints. Similarly, x equal to 5, y equal to 0. It is also a feasible solution because it satisfies the constraints. Therefore, from this example, we came to know that solution need not be a feasible solution, but a feasible solution may be a solution to the linear programming problem. Next one, basic solution. If there are p simultaneous linear equations with q unknowns, obviously q should be greater than or equal to p, then a solution obtained by comprising p variables in terms of the remaining q minus p variables, where all q minus p variables are equated to 0, then we get the basic solution to the set of simultaneous linear equations. Next, basic and non-basic variables. Basic and non-basic variables. The variables which are equated to 0 in a basic solution are called as non-basic variables, and the variables which are not equated to 0 in a basic solution, they are called as basic variables. Next concept, that is basic feasible solution. Any basic solution where all the basic variables are greater than or equal to 0, that means non-negative, then such a basic solution is called basic feasible solution. There are two types of basic feasible solution. One is non-degenerate BFS, and another one is degenerate BFS. Any basic feasible solution where all the basic variables are strictly positive, then it is called as non-degenerate BFS. And any basic feasible solution where one or more basic variables are exactly equal to 0, then it is called as degenerate basic feasible solution. Next, optimal solution. Any feasible solution which optimizes the objective function is called optimal solution. Next one, unbounded solution. If there are feasible solutions for which the objective function can be made arbitrarily large or small, then the linear programming problem is said to be an unbounded solution. Let us study all these concepts with the help of one example. Obtain the basic solutions to the system of simultaneous equations x1 plus 2x2 plus 3x3 subject to 2x1 minus x2 plus x3. So this is equal to 4, this is equal to 2. Here there are two equations, so p equal to 2 and q equal to 3. There are three variables. Therefore, I will equate q minus p means 3 minus 2 equal to 1 variable to 0 and obtain the set of basic solutions. Suppose if I put x1 as 0, then we get 2x2 plus 3x3 equal to 4 minus x2 plus x3 equal to 2 by putting x1 equal to 0. Solving these two equations, we get the values of x2 and x3. So if you multiply this equation by 2 throughout and subtract, then we get 2x2 minus 2x2 0, 3x2 minus 2x2 means x3, 4 minus 2 into 2, 4, that is equal to 0. So that x3 equal to 0. If you substitute x3 equal to 0 here, then we get 2x2 equal to 4, x2 equal to 2. Therefore, one of the basic solution is x1, x2, x3, that is equal to x1 is 0, x2 is 2, x3 is 0. Here x1 is called as basic. The variables which are equated to 0, they are called as non-basic variables. These are basic variables. So here both the basic variables are greater than or equal to 0, hence it is called a basic feasible solution. Similarly, you can find out by putting x2 equal to 0 and obtain one more type of basic feasible solution. Similarly, x3 equal to 0, you will get one more set of basic feasible solution, and you can verify whether it is a basic feasible solution or not basic feasible solution. So if the one of the basic variable is exactly equal to 0, therefore it is called as degenerate basic feasible solution. Okay, thank you.